easy, but you kind of need them for C and D. So we have to do like the whole question each time, but A and B are so easy that's not even difficult. Okay, so we'll start with sequences of diagrams, which is where it all comes from. Okay, so these questions, how do we do A? How do we do B?
So if we draw a pattern before space. So as you can see, every single time they draw like 3 dots.
And I think the easiest way to do it is to just add to the existing one. To the previous one.
Yeah.
So how would we use the previous one?
So you do 2 dots. You know the dot closest to the right?
Yeah.
Draw 2 dots to like sort of there.
Yeah.
And then draw a dot in the middle. Sort of like a bit across.
Yeah.
There, yeah.
Okay, so it's an extra 3 dots each time. Okay. And how about B? Any idea how you do that?
So it's pattern 15. Because 3 is 13, could you just do 13 times 5?
So you'd think so, but that won't work because they're going up different amounts for they don't work that way. What's good is you found some kind of a connection. So I'll write n for the pattern number, and then I'll write number of dots, and I'll make a table. So for pattern 1, 2, 3, 4, and then dot dot dot, pattern 15. So you said for pattern 3 there were 13 dots. What else can we get?
From pattern 2, there's 10 dots.
Yeah. Go on.
That one, no. 7. So it's going to have 3 every time.
Yeah.
So 4 would be 16.
That's it. And so this is basically, if it's going up in 3s each time, it's like the 3 times table, except it's bigger. How much bigger?
4 times.
Like plus 4. And so the 3 times table we write as 3n, like 3 times 1, 3 times 2, 3 times 3, 3 times 4. But it's 4 bigger, so plus 4. So how can we get when there are for pattern 15?
So you do 3 times 15 plus 4.
Yeah.
And 3 times 15 is 45. Plus 4, 49.
Well done. Yeah, so part A is easy enough. You just add on the 3 dots. And what that shows you is it's going up in 3s. So it's the 3 times table, except 4 bigger. So 3n plus 4. And then when n is 15, you work it out. Any questions there?
No, not really.
Okay, so I think this is the easiest way to do these. Make a table, find the rule, and sub it in. But there's no quick way. Okay, so we got 49, 1 mark, 2 mark. Okay, let's try these.
Space below, draw pattern number 4. So it's got to get pattern number 3. Obviously.
Oh yeah, so what would you add to pattern 3?
Just wait till you've got it.
I'll do it like this. Okay.
So from the middle line, you see like how there's triangles at the top of the first, second, and third one.
Mm-hmm.
You do that again with the 4th. So you draw a little, like that, and then one going down. Then a line going across. Then a line just below that going across.
Mm-hmm.
And then...
Oh, sorry, like that?
Yeah, like that. Then you draw a triangle going,
That's it.
Like that.
Okay. What's next?
Then that's it, isn't it?
So, sorry, that's A, and then how about B?
I'll be how many sticks are needed for pattern 10. Um, hmm, pattern 3.
Sorry?
Hang on, wait, I'm just counting them.
Okay.
So for the third one, there's 22 sticks.
Yeah, I think, okay, so let me do the table again. So N sticks, so when N is 1, 2, 3, 4, and then dot 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 10. So that one was 3 is 22. I think a quick way of doing this would be how many extra sticks did we have to add on
What do you mean
for A?
A? So there's 8 on the first one, the first pattern.
Okay. So how many red sticks did I have to add on?
You had what from the second to the third one?
From like our pattern 4.
Oh right, we had to add on 7.
So it means that they're going up in 7 each time.
Yeah.
So that will be the 7 times table, or 7n. And then pattern 1, so it should be 7, 14, 21. So what would you have to... Yeah, go on.
So it'd be 7n plus 1.
That's it. So I think that might be the quickest way to do these, actually. Count how many extra things you have to put on. So that's what they're going up in each time. And then compare that to the first one, which will have the fewest. So there's the least amount of counting. Okay, so this is 7n plus 1. How do we find pattern 10?
7 times 10, which is 70 plus 1, 71.
Well done. 71. I think that's going to be the quickest way to do these. Okay. 71, so 1 mark, 2 marks. It's blank for some reason. Okay. There we go. Okay, let's try this.
And 4. So.
Oh yeah.
Mm-hmm.
If I can. What am I doing wrong here? There we go. Yeah.
So you've got to draw an upside down triangle to the right of the triangle.
And so how many extra sticks?
God. 2.
Yeah. So upside down triangle like that. And the third side is already there. Okay. How about B?
B, complete the table. Pattern select 1 every time. It'll be 9 for number 4.
Mm-hmm.
11 for number 5.
Yeah, so 2 extra sticks each time, and so they're going up in 2s. C.
How many sticks make a pattern? 15. So do 2 times 15 plus 1. $31.
Well done. And the last one.
You want to work around 50. I've done a method you could use, so again just do 2 times 50 plus 1.
Okay. 2 times. What is that?
101.
So Okay, so I think you could say double 50, then add 1, or I think you could also put down as your answer 2n plus 1.
Yeah.
Any questions there?
No.
Just want to see. So these were each 1 marker. So adding on 2 or 2n plus 1. Okay. And I imagine if you put down 101, then, oh no, maybe you wouldn't get the mark. But if you wrote down 2 times 50 plus 1, then you definitely get the mark. Let's see. Yes. Okay. Let's try this one.
So just got to add another 3 squares and then make sure the middle one is shaded.
Okay. Yeah. Straightforward enough. Okay, part B.
A pattern in the sequence has 10 grey squares. How many white squares does the pattern have? I think it. Hmm. I think it would be 6.
What is the connection between the number of grey squares and the number of white squares?
There's 2 white squares for every grey square.
Okay. So 10 grey squares?
10, oh, it would be 20.
Yeah. And so now we're getting into the new thing, which is not just the pattern number, but also the things inside it. Okay. How about C?
245 squares. Grey squares. Hmm.
Any idea about this one?
I think that would be 15.
What's this thing doing? 15. So for this one, I'd have to make a table. So for pattern 1, let's see. So how many squares are we adding each time?
3.
And there are 3 squares in pattern 1. And so what did you say the answer was?
I thought it was 15, but I'm not sure.
I think it is 15. So for pattern 1, and then the squares, there are a total of 3. And it's going up by 3 extra squares each time. So it's just a 3 times table. So it's just 3n, or just 3 times table, 3 times, or working in reverse, 45 divided by 3. Explain how you found your answer.
Just did 45 divided by 3, yeah, and I got 15.
Yeah, so hopefully that's okay. Divide 45 by 3, or divide 30 by 2, or okay. Got it. Any questions there?
No.
Okay, so this one was a good one to start with. I noticed that the number of greys is the same as the pattern number. So like first one, second, third, fourth, and it's like grey is 1, 2, 3, 4. Eventually what you'll have to do is make a table, and it'll have n, it'll have grey, and it'll have white. And then you have to compare and contrast like n with grey, n with white, grey with white, and then maybe something like a fourth thing, which would be total squares. But anyway, we'll get there. Okay, let's try this.
How many stars will need for pan 5? 6.
Okay. B.
How many triangles are needed for pattern 6? Um, 11.
Okay. How about C?
How many triangles are needed for this pattern? A pattern in the sequence is made from exactly 10s. Um, and honestly, I'm not too sure about that one.
Let's see. Let's just continue up to when the stars is 10.
So the stars is 10.
Yeah, so let's just continue the table until we reach stars is 10.
Okay.
So I just have to move it over. Oh, it's not easy. That should work. Okay. Okay, so just keep going with the table.
Okay. So 7 would be so 7, 8. It'd be 8 stars, and there'd be 13 triangles.
And you can do them one at a time if you like. So do the stars first and then triangles.
Alright, so it'd be 8, 9, 10.
Mm-hmm.
And then it'd be 15, 17. And it'd be 11 and 19. I know we've got there in it anyway.
Yeah.
So it'd be 17 triangles.
That's it. So I noticed the stars are always one more than the pattern number.
Yeah.
I'm not sure what the connection is between N and triangles. I'm not sure what the connection is between stars and triangles, but you can see stars are going up by 1, triangles are going up by 2, but I think making the table was the easiest way to do that.
Yeah.
So number of triangles to stars. So they did it with some crazy method. No, let's just draw the table. Okay, this tricky one. Let's see. So this one, they've started it for you, so I don't have to do it.
I don't know. Space below complete pattern. You've just got to put. So you draw another line.
Which way?
You know, from where the line is on the right, you draw another line just below that, like in line with the others.
Oh, okay, yeah.
Yeah, and then one above as well. And then one down the right hand side. And then you draw 2 circles, like in between, yeah, like that. Yeah.
Something's missing.
And a circle in the middle.
That's it. Okay.
Number of lines in pattern 12.
No, part B, complete the table.
That we complete the table, so 11, 12, 13, so 13, 16.
Yeah, and for these, the reason why I've done it this way is because part B helps you with part C and so on.
Yeah.
Okay, how about this?
I think it's 47.
And how did you get that?
I just counted up in threes from, yeah.
Seems like a lot for pattern 12.
Oh,
Or what rule is it following if it's going up in threes?
so it's 3n plus 1.
Yeah.
And, yeah.
And so use that.
Oh, yeah. 3 times 12, which is 36, plus 1, 37.
Yeah. Okay, so okay, and then how about D?
Find the number of circles at 20. Um, um, so goes up 1 every single pattern and it starts at 5 and 6 and 7 and 8. So
Or what would be the rule for it?
I don't know. I think it'd be every pattern you add another one.
So it's going up in ones. So what would you do with that?
1n plus 4.
Yeah. Or n plus 4, same thing.
So that'd be 24.
Yeah. So that's 20 plus 24. Any questions there?
No.
Okay. Let's see. So that's it. 24 and 37. Just want to see if these are worth doing. So that's just A and just B. So these are really high markers. I just want to see this. How many squares? Oh, okay. Yeah, better do this.
Let me square that down in a pattern of exactly 14. So 2n plus. Mm-hmm. 8. There'd be 8. Pattern 8, yeah.
Pattern 8. Okay.
Yeah, there'd be 8 squares as well.
Okay. And 14. Don't think so. Hang on. So if it's with 14 circles.
No, it'd be pattern 6 actually.
Yeah, pattern 6. I think just doing it in your head you added instead of subtracted. Okay, and part B.
Part B, how many circles are needed for pattern number 50? So circles. What's 4 years? So 29.
And how did you get that?
I did because you're adding 2 every time. So I did 2n plus, yeah, it's 2n plus 2.
Yeah.
Did 50 divided by 2 plus 2.
It's not 50 circles, it's pattern 50.
Oh. I honestly don't know.
What does the n represent?
Number, sort of, yeah.
Pattern number.
Yeah.
Okay. How can we use that for this one?
So, 2 times 50 plus 2.
Yeah, because the
So that
pattern number is 50.
yeah, 102.
Well done. So for the first one, it was 2n plus 2 equals 14, and you solve for n. For this one, it was 2 times 50 plus 2, and you just work forwards.
Yeah.
102. Okay. This one, they made my life easy by saying fill in the next one. Find the grey squares in pattern 6. A pattern is 20 grey square. I think you'd be okay for that.
Yeah.
Let's see. So this is a simple pattern. Draw pattern 4. How many sticks? Pattern 12. Okay, let's try it. And it's easier if you do A, B, and C. Usually I say skip the easy one, but it makes it easier if you do the
Yeah. So when I'm going to say I should do first?
So just in order, A, B, C.
Alright, so you just draw a line going across from the top and bottom.
Mm-hmm.
And then a line in between them, like on the right, yeah.
Mm-hmm.
Yeah, and that's that. Number 4. How many sticks are needed for pattern 12? These are ones where I get stuck on.
So what I would use the term to term rule.
So you add in. So for number 1, there's 4 sticks.
Mm-hmm.
Number 2, there's
And
7 sticks.
The way I do it is like, how many extra sticks does it add on each time, and how many sticks would be in pattern 0?
None.
Well, how many sticks are you adding on each time?
So each time you're adding on 4, I'm guessing.
How many sticks did we add on for A?
3.
And so how do you represent that in the term to term rule?
3n.
Okay, so that's 3n. And then how many sticks would there be in term 0?
There would be none.
Well, if they're going up 3 extra sticks each time, then going down it would be 3 fewer sticks each time.
It would just be 3,
or no. So if you had to add on 3 sticks each time, if you're going down, you're subtracting 3 sticks each time.
Oh, 1.
Yeah. And so that would be 3n plus 1. Or basically, you can see how the first one has 4 sticks, so it has to be 3n plus 1. But the way you get the constant is like how many would be in pattern 0. Okay, so how many sticks are needed for pattern 12?
Well, so you got to do 3 times 12. 3 times 12. So 37.
Yeah. And C.
Number 3. Sunil says that he needs 26 for pattern number 20. Is Sunil correct? Well, yeah, it's definitely not.
What should it be?
So you need, because right, I'll do. Do you want me to work it out for you? Yeah.
Yeah, I think that's the easiest way.
Alright, so 3 times. So 3, so it's 61.
Yeah. So I
Yeah.
think that's the easiest way. Instead of a big long explanation, just work out what the right answer would be. So he's wrong. It should be 61 sticks. Yeah. So let me just go back. So for these in general, so part A, just draw on whatever extra you need. Part B is the term-to-term rule. So the term-to-term rule is always dn plus c, where d is the difference each time. However many extra things you had to add on, that's d. And for term 0 is c. And so you can just subtract d. So c equals pattern 1 minus d. And that's how you can get c. Or you can just kind of figure it out. You know, the 3 times table, 3, 6, 9, but the first one is 4. So it would have to be plus 1.
Yeah, okay.
Okay, so sequences of diagrams. What would you give yourself? X a half or tick?
Tick.
Okay. And I ended on the trickiest one. So next is sequences of numbers. So now there's no diagram to help you anymore. It's just pure numbers. So what would be this one on the left?
What are the first 4 terms of an arithmetic sequence? What's the next term is 65? $21.
Yeah. And how about the one on the right?
19.
And B?
Write down the 51st term of this sequence. The 50th term of this number sequence is 199. Okay.
And you can use how you got 19 to do this one.
What, just count it on?
No? How did you get 19?
Because I saw that you had to keep adding three each time, so then I realised that 15 plus 3 is 19.
You're not adding 3 each time?
Oh no, because yeah, that's what I did though. Like, because 3, 4, 4 even. I just counted up like that. Yeah.
Yeah. So you added 4 to 15 to get the next term. So the 4th term plus 4 gave you the 5th term. Okay. So the 50th term is 199. So what would be 51st term?
Oh, 203.
Yeah, that's it. And part C.
Let's see. The number 772. No, 372. Because all of the numbers in the sequence are odd. So, and 372 is an even number.
That's it. In sequence, odd, and 372 is even, therefore not in sequence. I don't know how much they want me to say. This is why. Okay. Let's see. Okay, let's try the one on the left.
On the left, here are the first times of a number sequence. Right on the next time. $19.
Yeah, so these are the exam questions. You can see how similar they are. Okay, yeah. Part B.
$31.
Let's see. Yep.
Yeah.
And C.
It's not. Yeah, again, because all the numbers in the sequence are odd.
Yeah.
And 80 is even.
Okay, and the one on the right.
Yeah, the first 6 terms of a number sequence. Write down the next one sequence. $29.
Okay.
So 45 is the 11th term.
Okay. And how did you find your answer?
I realised that the nth term was 4n plus 1. So I just did 4 times 11.
That's it.
Yeah.
Okay. So that was really what I wanted to check, and I wanted to check for the other one, but that's the easiest method. That's the best method. Let's see. Write down the next sequence. Explain answer. Yes. Okay. One on the left. No. Okay. Yeah. One on the left. Part B. You can skip the first two.
B. 45 is not a term in this number sequence. Explain why not. Is it because there's no multiples of 5 in the sequence?
That's a good answer. Yeah. Okay, and the one on the right, every question.
Write down the next term. So 19 is the next term in the sequence.
Yeah.
And I got my answer because he added 4 on each time, so it's 4n take away 1.
Okay.
Yeah.
1, 2, 3, 4, 5. Okay. 11th term.
So it's just 4 times 11, 43.
Yeah. And then the important one, part C.
Minor term in the sequence. Explain how you got your answer. Yes, a term in the sequence.
Explain how you got your answer.
Because if you do 4 times 20 is 80, and then you just take away 1.
That's it. 4 times 20 take away 1 gives you 79. A way to do these is so you were trying to figure out like what is the n? Is it 20? Is it 15 or something? What you can do is just do the term to term rule. So basically something like 4n minus 1, some n will give you 79, and then you just solve it.
Yeah.
So the whole add 1 to both and then divide both by 4. Okay. Because that one wasn't even or odd or anything like that. So let's see, those are the 1 mark, so we're now on the 2 mark. Hang on. So what are we doing now? Sequence of numbers. Let me just make sure. This is sequence of, oh, what is this? This is a sequence of numbers calculator, so that's the next one. This is sequence of numbers non-calc. Yes. Let me just check. Is this the one? No. Okay. Sequence of numbers. Non-calculator. I just want to see if I have a quicker way of doing this. No, I'll just stick to the exam questions. Let's see. All right, no, do it this way. So these are the 1 markers. Now I'd better stick just to the full exam question. I just can't. Okay, so let's try this one. And I'll just have to do this. Hang on, let me just go back to my thing. We stopped on first 5 terms, first 4 terms. Sequence of numbers, yeah. Okay, how about this one?
First 4 terms of an arithmetic sequence. What's the next term of the sequence? $21.
And part B?
4 plus 1.
So that's that. 4n plus 1. That's it. 4n plus 1. And this is 21. Okay, so once you have the 4n plus 1 thing, then you're doing well. Okay, this is it. That's a good one. Okay, how do we do this?
First 4 terms in a number sequence. Casey thinks that the number 34 is in this sequence. Is Casey correct? Show you've got your answer. So no, it's not.
Why not?
Because 3 times 10 is 30, and then you have to add 2, so 32 is bit, not 34.
What would be the term after this one?
Well, after 32?
Yeah.
35.
Yeah, and so you would need to say both is 35. So therefore 34 not in sequence. Or in general, because you're kind of trying to figure out what is, like, is it 10, is it 11, you know, and you're kind of guessing the numbers. The simplest way, 3n plus 2, so basically sum 3n plus 2 will give you 34, like that's what they're asking, and then you solve that. So minus 2 to both, that gives you 32, and so 3n equals 32, n equals 32 over 3, which is 10 and 2/3.
Yeah.
N must be an integer, like pattern number 1, pattern number 2, pattern number 3. There's no pattern number 1.5.
Yeah, exactly. It's got to be a whole number.
That's it. So n must be an integer, therefore 34 not in sequence. So that's a way to solve it instead of kind of guessing in your head, like, is it 9, 10, 11? Okay. Next number sequence. Oh, we did this one. Next number sequence, 8th term. Show number, we did it. We did it. Let me just see if I already have it. No, not that one. Okay, let's try this one.
Here are the first 4 terms of an arithmetic sequence. Find in terms of n expression for the nth term of this. Right. Six n plus 5.
Okay.
So, no, 121 isn't right in the sequence.
Why not?
Because 6 times 12. No, wait. 6 times 20, sorry, is 120, yeah?
Okay.
So, and then you've got to add 6. No, so then you've got to add 5 onto that. So it wouldn't be in there. So instead it would be 125. And then 6 times 19, 114. And 119's in the sequence as well.
So therefore 121 not in sequence.
Yeah.
Okay. Now remember, you can actually just do the whole 6n plus 5, which you got for part A, is equal to 121, and then solve it and see if it's an integer or not. So you're not guessing the stuff. That's the one we did. Hang on, no, I already have them. If this will work. 10th and 15th term. I think it'd be okay for that. So we did it. We did it. Did it. Did it. Yes. No. Possibly. It's an expression for the nth term. Yeah, get rid of that. That's the one we did. Oh. Find the 8th term. 7. Pattern 10 is right. 8th term. Okay. Now I think I'll just do the mixed questions now. Oh yeah, so these crazy ones. Any idea about part A?
Part A. What type of positive whole number is 2n take away 1? What does it mean by what type?
So I think what might help is if you actually just write them out, and then you'll kind of see it.
So 2n take away 1. So what does it want me to do? Find the first.
So what would be the first term, second term, third term?
Just be n. Then.
Well.
It would be 1. So 1.
Yeah.
1. 3. 5. 7.
And so what type of positive whole numbers are you getting?
Odd.
Yeah. And 2n plus 1 will give you the same thing, odd. Okay, how about B?
Write down an expression for the nth multiple of 5. What you mean? Does it mean by the sequence above?
No, totally separate.
So write down an expression for the nth multiple of 5. What, just 5n or?
Yeah, 5n. That's what it means. 5 times n. This one we did. This one we did. Fine. 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 Find the next term. Fine. Okay, how would we draw pattern 4?
So you draw a square on the, the bottom corner of the square on the right. Draw a square there.
Oh, okay.
Yeah, like that. Then you draw on connecting to the, the square you've drawn, the top right, and you draw a square connecting to that.
That is it.
And then you got to draw one be above that. And then one to the right of the middle square. And then you shade in every square but the middle one.
Okay. Okay, that's fine. Okay, how about this one?
Go the first 4 terms of the number sequence, write down the next term in the sequence. 22. Term in this sequence. 42.
And see.
And then 101. It's not a term in this sequence, so because it's only even numbers in this sequence.
That's it. 101 is odd. Sequence is even. So that's a recap for the other ones. This one. I'll leave that one. I'll leave that one. And that one I'll leave. And there's just one more type. I'm sure you'll be fine with it, but actually pattern, no, we did it. I'm just looking for one that we didn't do, but of that type. I was trying to find one that would throw you. Hang on, this one. Sequences of numbers calculator. How many white squares? Pattern. So this is the diagrams, which we're okay for. No, we're okay. So I was really trying to find one where I'd have to make you do the solving type, but you're pretty good at doing it in your head, so I wasn't able to find one. Yeah, so in general, with the sequence of diagrams, it always helps to write it as a table. So n for the pattern number, and then do it as a table. If you're stuck, the term to term rule is the easiest way, and then you either sub it in or solve it. How do you find the term to term rule for a sequence of diagrams?
You just count how many, say, sticks you've added on.
Yeah.
And then that's like the main number.
Right.
Like say.
So that's the number in front of n.
Yeah, and then I could sort of go backwards. Like for example, for pattern number 1, yeah.
Mm-hmm.
There, You've added on 1, 2, 3, 7, yeah. And for the first one,
Yeah.
yeah. You know what I mean?
Yeah, and then you can compare it to pattern 1. Okay.
Yeah.
The fancy way would be to find pattern 0, but you don't need that. I think that's the main thing. Solving it is that. And then for, let's see, these, so sometimes you have to make a table for everything and then use that to compare. So here we made a table for all 3 and just kept going until we got it. I think that was the easiest way.
Yeah.
Yep. So we use that pattern number. Let's see. No, it should be okay. So sometimes it's easiest, like, are they right? Are they wrong? Just find the right answer and just say, no, this is what it should be.
Yeah.
Sometimes it's simple, like they're all odd numbers, they're all even numbers. They all end in 5, but the number doesn't end in 5.
Yeah.
Okay, then for just pure number sequences, yeah, same thing. What they're going up in is the D, the difference, dn, and then you can compare that to the first one or find term 0 for the constant. For the pattern number, you sub it in, or to figure it out, you can solve it, but you're good for that. And it's just the same type of questions over and over again. But anyway, that's sequences of diagrams and sequences of numbers. How did you find that, Mikey?
That was good, thank you.
Anything in particular you want to do next time?
Well, I've got maths teacher gave everyone in our class a sheet, and there's topics that you're good at and topics that you need to improve on. So I could tell you one of them if you wanted.
Yeah. Go on, the topics you need to improve on. What are they?
There's angles and triangles.
Mm-hmm.
There's special offer problems. There's interpreting time series graphs.
Mm-hmm.
And then percentage of a number.
Time series. Okay. I'm thinking maybe equation of a line. I'll just take a look at that, because so special offers is percentages. The other thing was percentages of an amount, so that's kind of the same thing. Time series is a totally new thing, and so I'm not